Hi there. In this video, I'll go through some scripts and I'll share, of course, those that I've been using for quite some time in our pipeline to check dependencies inside the USD. And not just dependencies, but we'll check if there is an actual render settings and the camera set in the render settings as well. So you can be rest assured that your render will be as expected on a farm, on any farm, being on premises or in the cloud. And well, this is supposed to work just with layers on disk, not anonymous layer, not layers in memory. So if you are doing everything without baking anything, this won't work, but I'll go through this in a bit. And I will share as well this setup to further automate the submission kind of system with GridMarkets. This video will be shorter than the previous one, I promise. So let's go through it. And the first thing that I need to talk is this feature here that in the last time, maybe the fourth time that I recorded the last video, I forgot to talk about, and this is very important. So what is Husk actually? Husk is the command line batch kind of submitter of your renders to the render delegate. So Husk is the one that gives, in some sense, the USD file to the render delegate that you are setting to be the one that will render your scene. And it's not just a delivery system, but it has a lot of features as well, like something that we'll talk about in a minute, that are the Husk procedurals, but it sets the camera that will be used for rendering, because you can have multiple cameras. It sets the frame range that you will be rendering and things like that. And the first important thing about Husk is that it doesn't require a license. And that's pretty important, because when you render through Husk, it just kind of sends the USD file with, as I said, all the information to your render delegate, in my case here, Karma. And therefore, you would need just the license for your render delegate. And this is very important, because when you are thinking outside of being just the one-man band doing everything and rendering on your own machine, and you start thinking about having even being a small render farm or rendering in the cloud, the license count because they are expensive. What happens when you don't use Husk? When you don't use Husk, actually you will use Husk as well, but what happens is Python will be the one that will start first. Python is Houdini without an actual UI, but it takes a lot of time to open as well, because if you have a lot of HDAs and things like that to load, it will take some time. And then after this Houdini opens, kind of, it will then submit the rendering through Husk to your render delegate. It would be the same thing as having like a render wrap here, something like this, and rendering through here. So what will happen is Python will open your Houdini scene and then kind of press this button, and then it will trigger Husk that will deliver everything to the delegate, again in this case being Karma. So it takes more time, because Houdini takes several seconds to open. In a cloud render farm, that means that you are paying for this time Houdini is opening, and depending on your farm configuration, you will pay for this Python license, and they are pretty expensive because even being Houdini without UI, they cost a lot more than Karma licenses, and you can check that in the Deadline Cloud documentation. You see that it's sometimes costs the same as the machine, especially if you are using the rent licenses, and they charge per hour. So depending on the machine configuration you are using, it will cost the same or almost the same. So it kind of doubles the price per hour of your machine. So that means a lot that you spend with license. And if the render farm doesn't charge explicitly this Python license, you will still waste some time, therefore some money, waiting for Python to start, and then your rendering will start. So rendering through Python, it will be faster, even in your own machine, and I will show later in this video. So Husk, rendering directly through Husk is usually far better, faster. Well, it's better for everyone. And these Husk procedurals that may or may not, I'm not sure, will merge at some point with the new, they are calling calculations API inside USD. Let me show you. Here it's called OpenExact. It is not calculation, they call it computations. And well, you can read through this further, but as far as I understand, it has some concepts similar to the ones in Houdini procedurals. So what are Houdini procedurals? They are SOP code in some sense, SOP logic that you will execute at render time. So they are using that for things like hair simulation. You can simulate the guides and deform the full hair at render time, and I've used that last year, so it's pretty good. And yeah, the code logic, it's just SOP geometry, SOP actual SOP logic, and they are using SOP verbs actually, and that's the correct name. And the verb is actually the code inside the SOP. So they are executing the same as you would do in SOPs using this guide deform node. Let me just show you the idea. But in SOPs you have the guide deform here. And when you use the Husk procedurals, at least the Husk procedural for hair, it will execute the logic inside this. And as you can see, it's compiled. So everything inside it is verbified, therefore can be compiled and executed in this Husk procedurals. And you can imagine that it opens a lot of possibilities, because imagine being able to run anything you can do in SOPs, or almost, at least the verbified nodes at render time. So you can do like things like changing the points, and these points that you usually use for scattering, to the full geometry. You don't need to have that geometry in your scene graph. You can maybe instance that just at render time, maybe doing things like character deformation at render time. And when I say render time, it can be even viewport time. Just viewport is another delegate for the Hydra. So well, it's kind of a new world to to imagine and to discover, but it's not developed, but it's not fully open, so you can do anything you want, but at least you can start to imagine those things and keep an eye for new releases on that feature. So again, those procedurals, once you save them as geometry, because the SOP verbs, like those that I used in a compiled loop, a compiled, what's the name for it? A compiled block, they can be saved as geometry, similar to what Apex does. So if you don't know this, let me show just fast, and let me find the node. It took me some time because I forgot how to do that, but this attribute from parameters, you can point to a compiled block, and it converts this algorithm into geometry. So you can save this as a geometry. And as you can see, it has all the information needed to rebuild that algorithm. And for those who are or have some experience with Apex, you can see that this is very similar. The concepts are almost the same. And you can save this, and you can use this invoke graph to use that geometry to run this code that is stored in geometry, and runs this code in using another geometry, an actual geometry as input. So imagine you want to deform the geometry for this situation. You could use since here it uses the guides and the full hair to deform, and the rest guides. Here we would use the guides, the rest guides, and the full hair as well to run this code onto this other geometries as inputs. So what I'm trying to show here is the power of using these procedurals. So you can save this code as geometry and run it at render time. So what we have currently are actually procedurals for hair, and I think feathers as well, and for oceans. So that means at least for hairs, you just have to cache your guide simulation, and then at render time it will be the format that uses a lot less disk data than having to cache the whole hair, the whole animated and deformed hair that you would apply in SOPs. So when Solaris started, you would need to cache the whole hair with your simulation to render it. And now you just have to cache the guides, and that's a huge leap. And again, this is just to show you how powerful these Husk procedures can be, and that doesn't even need a Houdini license. So someone, TD, maybe can do these procedurals, and another person can use those in his shot, and then it submits to the render farm, and only a Karma license will be used. Right now, the GridMarkets farm, it doesn't charge less because you are using Husk, but I've been talking to them. Hopefully in the future, they'll be able to figure out something with side effects to charge less for the used license, since in reality, we are using actually fewer licenses. So, but anyway, when using this feature, you will have cheaper renders because they will start faster, because you don't need to wait for the item to start. So with that said, let me go through what I have here, because this part is really fast. I won't go through the code itself, but I'll go through at least what it does and where to change if you need. So now let me go through these scripts really fast. So they are supposed to be used with cache data. So imagine you exported, you baked your final layer with the render settings already set, the camera and everything else to make your scene whole, complete, so you can anyone that load it can render it. And this guy here is supposed to work just with those kind of layers, on disk layers, because it's trickier to make it work with anonymous layer. It works in some sense, but this was built to be streamlined in an HDA, in some pipeline. So this can be used in your own workflow, therefore, to be used with cached published data, not with data live from SOPs. Nevertheless, I've made some changes just to check if you have data from SOPs as well, but all the other configurations of this node will work only with cache data. Let me go through some of them. So here we have this guy here, the code is here, and I'm doing some kind of trick, and it's not fancy or polished. I'm not using in my pipeline this way, but if you need to change, the current behavior is scanning all the dependencies in the file, in the layer actually, and then it's storing the error messages in this dependency errors environment variable. And of course, if you use several of these nodes in your scene, it won't work because you would be duplicating this data. If you want to streamline this, maybe you should change this to maybe use some other system. Why I changed this? Because the way I use is using the message as an error in this Python script node. It's well, it will work with several instances of the node. The problem is with heavy scenes, it's very slow. The code itself is not polished, and that's because I'm not a very experienced TD with this USD API, so I'm using it now and then, and therefore some things are still a mystery to me. And well, the code is not polished, is not fast. So with a lot of layers, with a lot of data, it will be slow, and it's not supposed, again, it's supposed to be used with cache data, so no time dependencies. If you have time dependencies, this will become a nightmare. But anyway, let me change this, and I've added this option just for this video. But if you find this is a problem, just erase this line and this part with this 8 script code, and then remove this comment for this line. And let me show you what I mean. And as you can see, the error will be shown in this node, but the problem is it keeps cooking when you click here. I thought this maintain state would stop it, but it isn't. So this is well, for me it's a problem. That's why I changed this for this video. But usually I use just this because I just need to flag this error, and even being slow, it's for us, we still will be saving some time because we know that there's a problem, and we'll check again the source files. So now it's setting this environment variable, and this node is the one that is triggering the error. So this one will cook just once. And that's it for this system. And you can check here for SOP layers. So as you can see, it's erroring because it's a live SOP path. So the code is here. Where is it? Live SOP path here. So if you want to change it, and this is checking for SOP layers, so they are in-memory layers. But if you want to check for, let me see, other things, so this is for an ongoing project, and as you can see, it took several seconds because even being just a single layer, it has a lot of files, because this is an actual file sequence, a USD sequence. So it is scanning each one of them. And here we can check for the existence of the files as well. And again, it's a bit slow, but no errors right now. And it is checking for if the file exists, and it's checking for special characters, for white spaces, and for these formats. So imagine you don't want to use some specific formats, you can filter them here. Of course, you can change this. It will avoid this formats, these fields with these empty fields. And that's the idea too. So you can have some options to check your own files. And the code again is here. So here I'm using regular expressions to check for special characters. And here I'm using again regular expressions to check for white spaces. And that's the general idea. Let me disable this guy, because this one is another one that's kind of a big deal for us, because it checks for a render setting stream. Because usually I don't want to check anything when I submit a render to a render farm. I just want to see what someone on my team has done. So I want to see the image, the rendered image in the viewport, maybe a screen capture. And if it's okay, they will publish the layer, and I will just submit it to the render farm. So I don't want to keep checking for a lot of things. I want to submit it to the render farm. In our case, the GridMarkets, and that's it. I just want to submit it. And in the near future, the artist itself will himself actually will submit its own render. So I want it to function properly, and that's why we are checking for the existence of the render setting stream. And that's what is happening here. I'm not checking here for, oh, it's checking for the render products as well, but it's not checking for this field. So it's not checking for the product's name field, and therefore if it's empty, in our situation, there is something in place. Let me show you this one. And this node here, it's inside our HDA, and it's actually setting this the value for the render path, this product's name attribute. So I know, because I built that there will always have the value of the render path set. But if it's not the case for you, you should check for it as well. But I think that's easier to set. You can have an HDA with a karma render settings. So anyone that would be using your pipeline, your workflow, they would be using your render settings HDA. Therefore, you can script it, you can use expressions to make sure there will always it will always have the render path set. Therefore, it isn't something that you will need to check, and that's why I don't check for that. I'm just checking for the existence of the render settings and the camera. So this guy here is checking for the camera, and that's it. Because if there's the render settings and there's the camera, and it's not just having a camera, it's having a camera, as you can see, set in the render settings primitive. So it's I know that the camera is set for this render setup, and that's it. These guys here, they hopefully they will help you as they have been helping me and my team to avoid a lot of errors, avoid a lot of problems. That's why, again, I insist that we don't have any more render issues, especially with this new submitter from GridMarkets. And the last bit of this video is just to show you this system here. Here I'm overriding actually these attributes, the pixel samples. You can do this automatically here in the spreadsheet by right-clicking in any property, any attribute that you want to change, and then hit edit property. It will create for you these edit properties automatically. So that's pretty easy. And this is what I have done. It is getting the, what is it? It is getting the render path from the USD, actually from the USD, but from your layer, from your primitive, and changing here. It's changing the render camera as well and setting here. It's not changing the resolution, I think. Yeah, it's not changing the resolution, but well, I can add that. Hold on a bit. I made some changes here to get the resolution, and I fixed the frame range as well. And it's setting the resolution. You must set this as manual so it can get both the X and Y resolution and set it here. If it's like this, no, it is not erroring out, but all right. Yeah, we must not abuse of the code. So probably it will error out. Let me check. Yeah, it will error out if you don't set as manual, because it tries to set this and it's blocked. So that's it. And this node is getting this name here and here, because the submitter, it saves well, the kind of final layer, and in this layer it will store this last overrides that we are setting here. Of course, in the future, I hope we can avoid this step and send the layer we are loading directly to the farm. But as it is right now, it is saving another UC layer. It's a very, as you can see, lightweight file, because it has just the references and this overrides, of course. But all this information is being set automatically, and this as well. Just the project name, I think it's not being set automatically, but the submission name, it's being set from the first node above here that doesn't have inputs. So this code here is figuring out which node doesn't have input, so it goes upwards, and when it finds the node without inputs, it will grab the name and set here and here. So that's it. We have a fully automated workflow with with the GridMarkets system, render farm, whatever. And one final thing is this render settings that is unlocked. It is unlocked because I'm just using this information for this actually the meter internally. It needs this, it uses this output picture and the camera. So I'm using this information just because it needs, and I think it's actually overriding this. Let me check. Yeah, I found it. Actually, I'm not using the resolution. You can, yeah, you can change it here, but actually I'm not using it. So that won't change anything. Let me show you. Yeah, it's not changing anything, as you can see here, because I went here and where is it? Yeah, here, and I changed it to this do nothing. So that's it. I'm just setting the information because the submitter expects it, but that's it. So that's the general idea. I will share a file I'll show in a second with just these nodes and these nodes. I will update the last, the file from the project file from the last video with these nodes, but I won't share the submitter because it will error out if you don't have everything set with GridMarkets. So I won't share this, and I will share this as disabled because it is expecting this GridMarkets node. It's going just after the camera render settings. So that's the idea. Just it's finding this render loop and then getting the first output. So if you set multiple outputs, it will error out as well. You have to change the code, but that's the general idea, to have this Python script right above the camera render settings, and after that this GridMarkets submitter. So I think that's it. Let me just show you this in the file and I will wrap up this video. So let's wrap this up. And some things that I haven't mentioned on the last video, when I was caching this render layer, I'm just caching this amount of instances because it takes a lot of time to build the stage with well, the full amount of instances. That's not the idea of this video. But it was complaining about some nodes without a safe path, and that was here and here. So just let me complement what I did in the last video. And since I have cached this guy and this guy, but this guy haven't been cached, you can imagine that we have live data here being sublayered, and then we did another thing on some other steps after this node. And the thing is, we are doing some processes in a certain order, but with data from disk and with data live, not live, but from memory. So we can't save this data afterwards. So if we try to save this without this cache, it will complain and it will save this as another layer on disk, and this as well, it will save as another layer on disk because of the order. So I hope it makes sense, but we can't um, like do this process in this order with data from disk and with data in memory, because if we save this afterwards, it doesn't make sense because here we are using this data previously. So the reason is the order actually. That's why we need to cache this and use all this data from disk, from layers from disk. And so keep an eye on this layers, the number of layers that you see in the nodes. So you can mix. Actually, you can, but Houdini will save the layers in memory that you are using previously on disk. It can't save everything that you are using here on the final layer. Again, because the idea is you need the data before, so that's why it saves this on disk, and that's why we can't just flatten these implicit layers because of that reason. As you can see, they are implicit, but we are using that before, those layers before, and that's why it can't merge in the final layer, because the order you have implicit layer, you have layers from disk, and then implicit layers again. And because of the layers from disk in the middle, you can't sandwich the implicit layers before this one. That's why you should do this, and I would avoid doing flattening the stage afterwards, because again we would save all the data again. The real-time samples is actually not for this, but it changes a lot of things in the layer. Not when we, oh, actually, let me see. Yeah, not for this. Yeah, here. It will change a lot of things when we use the instancer, because where is it? Yeah, here. Now, yeah, now I have the point instancer with all these prototypes because of the the time differences, as I told you before on the last video. So here, let me cache it again. And let's see what happens when we save this one. As you can see, it doesn't complain even doing this amount of changes in the stage, because since these live changes, this implicit layer, as you can see, 3 to 4 layers, it is after those on disk layers. So all this data that is being set after this sublayer 2 node, they can be sandwiched in a single layer. So if you save this as an USDA, or we can actually do this here, right? Yeah. As you can see, all those changes are being set in this final layer, but because of the reason I just told, these implicit layers, they are all in the same kind of time on your procedural USD you are building in Solaris. So everything here is actually here is implicit, so they can be sandwiched together. One last time, I hope it makes sense. If it doesn't, just reach me out. So here is the setup I just told you. I had to change this because I'm using Google Drive, and unfortunately Google Drive, this is in Portuguese, but it uses this white space. I hate this. I've complained with them. I complained with Dropbox. We use now what I think is the best service for this is LoosLink, but with for file transfers we still use Google Drive. So that's it. It's working. We're checking the camera. We have a camera set that I've set here. And I left this message just for to remember that for the GridMarkets automation to work, we need the submitter after this node. And I'm using here the first node without inputs to get the it's not here, it's here, to get this name and this name. So if you are using a different workflow than this, if you are using something like this on everything on a single scene, you must change this code, especially not here, this node. You must change this to get a specific node. So that's it. If you have problems changing this, just reach me out again. So I think that's it for this video. I hope that it helps solving your issues. I think I added some extra info with this way that Solaris is working, like merging stuff, merging layers and everything else. And of course, I hope this kind of automation helps you as it had helped me a lot, and it still helps with our process of submitting our renderings, of our process of checking our dependency. Sometimes a user is still getting some file from elsewhere, and with this kind of automation we can check that, we can make sure that everything will be in the right place, so when we submit it to a farm, uh, the render will be outputted as expected without any missing part. So I think that's all for this video, and well, I see you on the next video.